Hi, today we're going to talk about Pascal's triangle. So, to form Pascal's triangle, you take 1 at the top, and then 1, 1, 1, 2, 1, 1, 3, 3, 1. So you can see that we're taking for each value, we're taking the two values above that value and adding them together. 1, 4, 6, 4, 1. And you also notice that on both sides we're taking 1s. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And you also see that if we draw a line straight down the middle of the triangle, it's symmetrical for both sides. So those are some properties of Pascal's triangle. Now, how can we use this? Surprisingly, you can use this in a lot of ways in mathematics. So if we have x plus y to, say, the third power, how can we use Pascal's triangle? Well, if you don't want to multiply out x plus y all to the third power, you can actually look to the third row of Pascal's triangle for your coefficients. But you have to remember that this row here, this single one up here, counts as row 0. So you have row 0, row 1, row 2, row 3, 4, 5, and 6. So those are rows. So for x plus y all to the third power, we're going to look to the third row. So 1, 3, 3, 1. And since we have a plus sign right here, we are going to put plus signs in between each of our coefficients. And next, so this is the tricky part, we're going to take x, and starting with the left side, x is our left term in this parentheses, so left side, x to the third power, and then x to the 3 minus 1, so x to the second power. I'm sure that you're going to notice a pattern here. X to the first power, and then x to the 0th power. And then, if we take the y, the right term, and we start on the right, we take y to the third, y to the second, y to the first, and then y to the 0th power. And that will actually be what we get when we multiply this out 3 times. So we can simplify this. X to the third power plus 3x squared y plus 3xy squared plus y to the third. And that is our answer. So let's try a harder one. Let's say that instead of just x plus y to the third, we have x plus 2 to the fourth. For this one, we look at it, our Pascal's triangle again, fourth row. So 1, 4, 6, 4, 1. And we'd have plus signs in between all of these since this is positive. And then x to the fourth, x to the third, x squared, x, and then 1, because x to the 0 is always 1. Going the opposite way, 2 to the fourth, 2 to the third, 2 to the second, and 2 to the first, to the 0th, but again, that's just 1. So, if we simplify all of this out, we get x to the fourth plus 8x to the third plus, let's see, 4 times 6, so 24x squared plus 32x plus 16. And that is our answer. Now let's say we have an even trickier one. Let's say that instead of plus 2, it's minus 2. We don't have that plus sign in there. So how are we going to do that? Again, we look to the fourth row for our coefficients. 1, 4, 6, 4, 1. And instead of putting a plus sign in between each of our values, we're going to alternate. And we're going to start with positive. So this is a positive 1. This is a negative. This is a positive, negative, positive. Next, we go x to the fourth, x to the third, x squared, x to the 0 is just 1. Next, we take the 2 here, just the 2, not the negative, and go the opposite way. 2 to the fourth, 2 to the third. Sorry if you can't read my writing there. 2 squared, 2, and 2 to the 0, which is just 1. So, and if we simplify this out, we get x to the fourth minus 8x to the third plus 24x squared minus 32x plus 16. Now, why do we alternate the signs though? Well, if we were instead to take, instead of the negative and the positive 2, if we just took x plus negative 2 all to the fourth and actually put in the negative in here, we wouldn't need to remember positives. But a lot of people find it much easier just to take the positive 2 here and then account for the negative when you assign your signs right there. So that's the Pascal's triangle.